Let's get straight into it. It's my real pleasure to introduce Dr. Steve Denton to us. Most importantly to me, he's a good friend. We work very closely together in the UK. He has a very long list of accolades. I'll do my best to summarise it. He's an executive director at WSP UK, leads a civil bridge engineering team of 750, technical excellence function of 9,000 people in the UK, vice president Royal Academy of Engineering, which is prestigious. He's the chair of the entire Eurocode committee, which is used by hundreds of thousands of engineers across the UK and the world, and a visiting professor at the University of Bath. He gave this presentation 2 days ago, and it was excellent. So I'm really stoked that we could hear about design standards, simplification, and ease of use. So without further ado, Steve.
Kia ora. Tēnā koutou, moto, mana te kanda, ki aha. Thank you for that. A thank you for the welcome, and a thank you for inviting me to come and speak to you today. It's a real pleasure to be here. I hope you can hear okay online. Is this coming through? You can hear me okay at the back? Look, just tell me if it's not loud enough, and do feedback if it's not clear enough online. To those online, I'll probably wander around a little bit, but hopefully you'll still be able to see everything okay. Look, it's a real pleasure to be here. I've been in New Zealand all week. I was in Australia last week, having a fantastic trip. It's a huge pleasure to be here. Spend time with my colleagues from WSP and with a lot of other people at a big conference that we've just had in Christchurch this week, as Jono mentioned. Kind of like this quote. Does that resonate with you? It kind of resonates with me a little bit, yeah. But you know, this quote also it kind of intrigues me a little bit because this quote's taken from a discussion that was held at the headquarters of the Institution of Structural Engineers in London. And it was a discussion that was held there just a few days after I was born. So this issue that I'm talking about this evening about complexity in standards, simplification in standards, what we should expect of standards, and what the right, that's a discussion that's been going on for a long time. And so I want to share with you today a few of my perspectives on this. And as Jono said, this is an area where I've been at for quite a few years now. So I hope that you'll find these insights interesting, hopefully useful. So look, let's get stuck in. In terms of increasing complexity, it's certainly the case. My colleague and friend Marion Angelina, when she was doing her doctorate, she was looking at design standards, and it's definitely the case that when you look back through history, the volume of standards has increased. No question that that's happened. I always think it's instructive to kind of go back in history and look at things. If we go back about 4,000 years, the original design standard, the Code of Hammurabi. If a builder has designed and built a home and his work is not good, and if the house he has designed and built falls in and kills the householder, that builder shall be slain. For those of us in the sort of standardization community, we kind of look at that and think, it's interesting that even 4,000 years ago, people were writing performance-based standards. And for those of you who are involved in contract negotiation, it kind of made me smile when I looked at this, that even back 4,000 years ago, they were using pain-gain contractual mechanisms, although in those days they focused more on the pain. But I'm not going to be taking too many examples from that far back. I'm going to be focusing mostly today on their evolution. So this is a really sizable program of activity that's been happening in Europe to develop the second generation of the Eurocodes. But it's probably worth me just doing a really quick overview of how the Eurocodes work. So the Eurocodes are the standards for design for buildings and civil engineering works across Europe. So it's a single suite that covers all facets of civil and structural design, including geotechnical design. So there isn't a separate suite of standards for bridges and separate standards for buildings. It all sits within one integrated suite. And for the last 10 years, we've been working really hard on developing the second generation of these standards. And that's been by funding level, that's been the largest standardization program ever in European standardization history. As I'll come on and talk a little bit more later, there have been thousands and thousands of experts involved in this effort. But the thing I wanted to just mention right at the outset is I can remember way back in 2010, just as we were doing some of the planning for this program, sitting in a meeting room overlooking the harbour in Helsinki, and we were debating simplification. And the European Commission had challenged us a bit and said, when we're working on the second generation of the Eurocodes, can we think about simplification? So this topic, this concern, this, where should we place ourselves? What should our ambitions be? It's the right level of complexity and standards was something that was kind of front and center of our minds as we embarked on this huge program of Eurocode evolution. And as John said, and I've kind of outlined, this has been something which I've spent a significant amount of time working on over the years. And, hopefully some of the things I'll share with you today might challenge your thinking a little bit around standards and what we should be doing. And so I hope it's going to be worthwhile and interesting for you. That when you're going to listen to someone for a little bit, and you're going to hear their views, it's always interesting to know what their viewpoint is. And so as Johnny said, my day job is as head of civil engineering for WSP in the UK. So I lead a unit of about 750 staff. Very much my way of doing that is I spend at least 50 or 60% of my time working on projects. So I stay close to clients, I stay close to colleagues, very much the way I approach it. I've been chair of TC250, that's the committee responsible for Eurocodes since 2013. I was elected last year as the Vice President of the Royal Academy of Engineering, which is a tremendous honour that gives some real insights around kind of engineering policy and strategy across the profession. I've had the visiting chair of Bath for about 15 years now, which kind of gives me a sense of some of the challenges around engineering education and also an opportunity to be involved in research. And then I've been an advisor to clients and governments for decades now. And the reason it's maybe helpful to mention those things is, principally when I work on standards, I do so from the perspective of a practitioner. But those other roles, I think, give me some useful insight into the other users of standards and their perspectives as well. So look, what I'm going to do this evening, and I'll move reasonably swiftly through this, but I'm going to move through 7 sections here. The first 3, kind of looking backwards a bit, or at least setting context. Okay, that's the first 3. And then the next 3 are looking forwards, where I feel standards should be heading. And then there'll be some brief conclusions towards the end. So this is where I have to apologise to Jono, because I kind of failed him and maybe failed you a little bit, because I have the most fantastic job. I think I have the dream job. I get to lead this amazing group of 750 people. We work on astonishing projects. And I kind of, you lead a group like that, you kind of get to pick your projects. So I'm involved in nationally, internationally significant projects. It's a fantastic role. And I said to John, any tips, any things I should do for tonight? He said, well, do you know what you should do? Because it's a lot of bridge engineers, at least have a photograph of a bridge. Well, I kind of failed you because I failed to put in any photographs of bridges. But there's some concrete coming up, but there isn't a bridge. But I do have the most fantastic role. An absolutely brilliant role. And given that I can do all of those things, why do I spend time working on standards? It's not the most glamorous field, is it? I'm bold of you to come and spend your evening to hear someone talking about standards for an hour. It's like this is not the glamorous end of our profession. So why do I spend my time? I spend my time on it because I think it's really important. Okay, and I'm going to outline to you why I think it's important. The first reason is about impact. As John already outlined, when the Eurocodes were first introduced, the European Commission did an assessment of the number of engineers that would use that suite of standards. This back in 2006, 2007. And at that time, the estimate was that the Eurocodes would be used by over 500,000 engineers. And that was in Europe, and now they're used in many other countries around the world. Construction represents 6, 7, 8% of GDP in most developed countries. Eurocodes and their equivalents, the design standards that underpins that huge part of our economy. And so the impact of these standards is enormous. You know, it's something that if I'm sitting in a committee room in Brussels, I'll always remind the team I'm working with that we're going to inflict those decisions that we take on 500,000 engineers. We need to get this right. So impact is the first thing. The second is that in the construction sector, we operate at a scale that means that it's almost impossible to test, to prototype most of the designs that we do. You know, and think for a minute, because that's different from almost all other branches of engineering. In most other branches of engineering, things are tested in labs and factories. We get very little opportunity to test our designs in the same manner. So what do we need? We need a means by which we can verify the adequacy of our designs before they're built. Yeah, that we can verify the safety, serviceability, robustness, durability of what we designed before it's built. And that's the fundamental role of design standards. As I outlined, that's almost unique for the construction sector because of the scale at which we operate. You know, one of the other characteristics of the construction sector is that it's incredibly fragmented. The number of different parties involved in the construction sector is enormous. When you think about the number of parties involved in a project. And what's the consequence of that? One of the consequences of that is that it's really difficult as a sector, as an industry, to learn lessons. You know, it's different if you kind of contrast it with, say, automotive, where you kind of know that the car manufacturers, for example, have had line of sight from concept design to having garages that maintain the vehicles. They have touch points all the way through. It's not like that in our sector. It's really hard. It's really hard to learn lessons. It's really hard to have feedback. But standards play a really significant role in enabling us to do so. And we know that's true because when you look at the history of standards and you look at the history of those occasions where as a sector we've learned lessons, either because understanding has advanced at pace or more sadly, where there's been some kind of failure, that's very often been the trigger for a period of heightened activity in improving and updating standards. It's a fundamental mechanism through which we learn collectively. Also fundamental in terms of the way in which we can transition what we do at pace to meet new societal demands. And obviously one of the really central and key challenges there at the moment is around sustainability, around decarbonisation, around climate resilience. When those demands change, we can make progress, get traction by embracing them within our standards. And then the final one around research and getting research into application. Why do we do research? We do research to enable us to innovate. What do we want to achieve from our innovation? Is we want to achieve impact. And impact needs scale. And what better way to get scale than for the research to transition into standards? There is no better, I don't think there is no better pathway to impact from research than through those research findings informing standards. So, you put all of that together, and those are the reasons why I spend quite a lot of time in this space. I think it's really important, and that the conference that we've just been at in Christchurch, I sat in a lot of sessions, and there was not a single session in that whole conference. It's a fairly academic conference. There was not a single session when someone did not talk about standards and the provisions within standards. They just affect our day-to-day work. So how do we make them as good as we can? Okay, so next section, explanatory power and simplicity. So I'm sure for some of you it's been a long day. For me, it's been a long day. I started today at a little after 4 o'clock this morning. But it's never too late to get into some really fundamental structural mechanics. Okay, so that's what we're going to do now. So
So that's a test from when I did my PhD. And the reason the image is so dreadful is because it was 25 years ago and digital cameras were rubbish then. All right. So I need to find and I've got some like proper photos. I need to go and scan one because it's rubbish, isn't it? Anyway, what you're looking at is a test specimen of a concrete slab, and you're looking at the tension face of it, and it had a load sort of just near side, just around here upwards, and I get to talk to lots of practicing engineers. I've done loads of training sessions over many years, talked to hundreds and hundreds of practicing engineers, and I'll show them this photo, and I'll talk through with them how you can kind of see what happened in that test. So in that test, when that load started being increased, initially what you saw were all those diagonal cracks, a kind of elastic response. And then subsequently it formed a yield line mechanism across the middle. And the question that I'll ask those groups of designers, practitioners, is how would you design a concrete slab like that? How would you go about doing it? Just do that. The answer I normally get back is, well, I do, because it's a non-symmetric case, I need to do some kind of analysis. These days, I probably just do a simple linear elastic finite element analysis. I get my moments out of it, and then I design based on the moment results. I can see a few nodding heads. That's what a few of you would do. But I think what's interesting about it is that it's really clear from that photograph that the ultimate limit state distribution of moments is nothing like that elastic distribution that you'd use for your design. Nothing like it. So the next question I ask a room full of practitioners that I could ask you, just an important, if slightly provocative question, is if you're designing for a completely different set of moments, how do you sleep at night? How do you know it's right? How do you know it's safe? I'm not going to ask you. I'm grateful that you've come to the event. I'm not going to give you a hard time. Right? Relax. I could see a few people looking slightly nervous, thinking a little bit in your seats. I'm not going to do that to you.
You look at collapse mechanisms.
Well, you can look that way. The other way you can look at it, and where we'll often get in those conversations, is actually what's going on is that you're relying on the lower bound theorem of limit analysis, plasticity theory. That theorem that says if you can find a distribution of stress resultant moments throughout the structure, which is in equilibrium with the applied loads, nowhere exceeds the capacity, that can safely be kept. A really profoundly important theorem that underpins so much of what we do. And I call this section explanatory power. There's a really nice kind of model, I suppose, within the philosophy of science that talks about explanatory power. And explanatory power is that idea that you can have a simple theorem that explains loads. So natural selection and evolution is a kind of classic case. You make one simple theory and then so much comes out of it. I tend to think of limit analysis, plasticity theory as being almost like our engineering equivalent, because this is so powerful. This means that we don't have to worry about the whole load deflection path of a structure. We can get to its collapse load directly. Super, super powerful. And it's got a whole host of corollaries that flow from it. And one of them is that you can't make a structure weaker by adding material. Another is that you can't make it stronger by taking material away. Actually, I'm not going to go into all that detail. I was going to go, but I'm not going to do it. It's a professor of structural engineering who picked me up after the talk I gave. Yesterday morning. It was yesterday morning. The day before? Yes, no, it was yesterday. Yeah, it was yesterday. And pointed out that there's but that doesn't hold if you've got fracture mechanics. But anyway, that's what I'm talking about.
So let's design.
No, that's just the low. Well, that's telling you that you can do elastic design. It's telling you that you can do elastic design. One of the other corollaries, one of the really useful corollaries to this, is it says that the addition of a self-equilibrating stress system cannot make your structure weaker. Which tells you that you won't make yourself structure weaker by having a stress system that arises, for example, from restrained thermal movements. Super, super powerful. Simplifies things significantly. Of course, every theorem has assumptions. There are 4 behind this. Okay, this only holds if displacements are small, if materials are ductile, and then the 3rd and 4th one are kind of in the weeds, really. But you need the yield surface of what you're looking at to be convex, and you need this thing called the normality condition to apply to it. But a lot of materials that we look at, the 3rd, 4th one will apply. Okay, so focus on the first 2. Okay, small displacements, ductile materials. And it's interesting when you start scratching the surface of standards. So now we'll go back to the Eurocodes. And you'll see in the Eurocodes, 2nd generation Eurocodes, so the new ones, we say the effect of restrained, imposed deformations may be neglected at ultimate limit state. Tremendously simplifying statement. Tremendously simplifying statement, yeah? But you can kind of tell from the fact that I've left a colon there that there's a little more to come. So what else is he going to say? What it's going to say is you can only do that if there's deformation capacity, ductility, and displacements are small. And if that isn't true, then it all gets more complicated. And the point that I want to make here is that if we were happy in all cases to prevent second-order effects and to use ductile materials, we wouldn't need the complexity that follows in Annex D and elsewhere in the standard. We make a choice. We make a choice that says, actually, we want to use more brittle materials. And it's a trend in our sector. We're looking to use higher strength materials. Higher strength materials tend to be more brittle. You look out the window at some of the structural forms that get designed, they're more affected by second order issues. Yeah, so we're making a choice. If we want to use those more brittle materials, if we want to design structures that are more influenced by second order effects, we need the tools in the toolbox to be able to deal with that. And those tools bring complexity. And I had having a conversation with one of my engineering heroes, a guy called Peter Marty, who was the professor of concrete structures at ETH in Zurich, and amazing, brilliant engineer. And I was doing, this is back 25 years ago, and I was doing some of the early work in the use of FRP materials for strengthening structures and wider sort of applications of FRP materials. And I was talking to Peter about this, and I was saying, well, are you interested in this? Are you going to go do any research in this area? So he wasn't going to, because he was really interested in designing structures so that they were predictable because they had ductility. And it was an interesting perspective. It's like he was making a choice. No, I'm going to design structures so that they are simpler to analyze. But you get my point, that you can, that when you're designing things, we're to some extent making a choice. The thing I pointed out to Peter, though, was that might be true in design, but a huge amount of our work these days is in assessing existing structures. And when you're assessing existing structures, and the Eurocodes are being extended to cover, at least in part, assessment of existing structures, when you're assessing existing structures, you don't have that choice. Yeah. But what you have to analyze is what you've got. And you probably don't have perfect information about it either. Yeah, so in that situation, you haven't got that flexibility. You can't make that choice. You need the tools in the toolbox that enable you to do the analysis that's demanded by that structure. And again, it's interesting for me around design standards and assessment standards, because I've been party to many conversations over the years where people have sort of talked about or implied that assessment standards are like a little extension of the design standard. In my experience, that's completely wrong. But actually, the assessment standards are the general case, and the design standards are the specific case. The thing is that in design, you get to choose your materials. Yeah? You get to choose your construction tolerances. You get to choose your detailing. Yeah? So it's a constrained problem. In assessment, it's not a constrained problem. In assessment, you just got what you've got, and you've got to be able to have the tools to be able to analyze it. And crucially in assessment, if you're assessing an existing structure, the value of doing that accurately is huge because it makes the difference between leaving a structure in service, extending its life, or having to deploy some kind of strengthening or replacement, which obviously has significant economic consequences, it has social consequences in terms of disruption, but crucially it has major carbon consequences. And I do think that one of the best things we can do as bridge engineers to contribute to decarbonisation is to extend the life of the existing structures that we have. A really key contribution for us to make. So I guess I'm starting to unpack my thesis a little bit here. Yeah. But that complexity is there for a reason. Right? I'm going to go a little deeper into that. So now looking at EN 1992 and what's happened to Eurocode. So a little bit more on the program, because it kind of gives you a little bit of a sense of the richness, thoughtfulness that's gone behind this program. So I've already mentioned the structure of the Eurocodes. This is the structure of the TC250 organization that's done all the work on the Eurocodes. And one of the other layers of complexity that's really important when you're thinking about the Eurocodes is that, and it's true of any standard actually, but I've been talking, and I am talking about the Eurocodes, the design standards. But standards work as a suite, they work as a family. You know, the design standards have to work in conjunction with the product standards and with the execution standards, the construction specification standards. You know, the point being that if you're looking at the buckling of a steel member, yeah, the load that steel member will buckle at is going to be dependent upon how well it's been manufactured, its straightness, and it's going to be dependent on how accurately it's installed, the construction tolerances. Yeah, what you have to do is you have to put some assumed tolerances into your design standards, and then you have to specify those as requirements to be satisfied by your products and in your construction. Yeah, so these things all have to tie up, they all have to link up. And one of the other interesting things from the perspective of developing the Eurocodes implemented by 34 countries. So you've got to provide that layer of national adaptation to fit within the regulatory regimes across 34 different countries. So we have that layer that we have to accommodate as well. And in terms of the development of the second generation of the Eurocodes, the European Commission recognizes the importance of this suite of standards. I've already kind of indicated that by the fact that they invested more money in the development of the second generation Eurocodes than they have previously in any standardization program by a factor of about 5. But the Commission set out and shared with us their aspirations for the second generation of the Eurocodes, the strategic direction that they wanted them to go in. And importantly, in those days we used to call them mandates, these days they're called standardization requests, but that unlocks a funding opportunity as well. So this kind of shaped the strategic direction. We had about 1,000 engineers across Europe worked on the response to this, put together a whole program, how we're going to respond to it. So it was part of the picture. The other thing we did was we went out to all of those 34 countries, each one of the 59 Eurocode parts, and we said, give us your feedback, clause by clause, what you like, what don't you like, how can this be better? Collected thousands and thousands of comments, each one of them catalogued, responded to, and then brought that together to shape the evolution of the Eurocodes. And again, just to give you a little bit of a flavour of the scale of this whole endeavour, last time I counted them, which was a couple of months back, we had 129 active subcommittees, working groups, task groups working on this programme.
I mentioned that interface with the product standards. We had 46 active liaisons across to other technical committees. We used most of that funding from the European Commission to set up 76 funded international project teams to work on different facets of the suite. In standardization, the standardization rules within Europe say that you have to go through a process of formal inquiry when people get to comment and formal vote. Given the scale and importance of this program, we didn't feel that was enough, so we added 3 more rounds of commenting into that process. So there's been more than 300 opportunities to comment. We delivered a lot of this during COVID, and despite that, we managed to deliver all of that work on budget and to program, and we didn't get any queries about anything that we provided, which was quite something. And in terms of the scale of this, my estimate is that there's around 1,500 experts who have engaged at the European level in this work. But of course, they are just a member of the mirror committees that exist within all of those countries. So I think that probably in terms of the total number of experts who've been involved in this program over the last decade, it's probably over 10,000. So it's a big program. And then, where have we landed? Where have we landed with EN 1992? So I'm focusing on EN 1992 just as an example, but I could have used any of the other Eurocode parts. This is where it landed. So this is the new structure of concrete Eurocode. We use a consistent structure for each of the parts, so it's kind of easier to navigate. And the new version is a little over 400 pages long. And I know when I share that with some colleagues, UK or elsewhere in Europe, it's like, what have you done? Like, do we really need 400 pages? Because that's not the whole standard, because you need the other ones as well. You need the loading parts, you need, really, that really necessary? 150 pages in 19 annexes. Is that right? Is that progress? Do we really need an annex on stainless steel reinforcement or steel fiber reinforced concrete structures? Do we really need that? We could take it out and make it shorter. But I think when you kind of think about these questions, you've got to think about the counterfactual. I mean, if you don't need those annexes, you don't need to look at them. But if you're working in that field, you're going to need to get the information from somewhere. And if you go somewhere else, then you've got a lot of thinking to do about, well, is that information I got from another source compatible with the rest of Eurocodes? Are people going to see it a similar way? Clients confident in how it's going to be handled? So is it simpler or more complicated to put that material within the standard or have it separate? I think what I suggest is that actually it is easier to have it within the standard, although it does make the standard bigger. So let's keep digging into this a little further. So we talked earlier about, that critical societal challenge around sustainability. Absolutely vital. Also big challenges in terms of economic costs, carbon costs critical for us as well. So what have we put in the second generation Eurocode to help with that? A host of things to enable us when we do designs to use materials more efficiently. So unlocking opportunities for more complex and sophisticated needs of analysis, including opportunities to adjust partial factors, safety factors, where we've got better information, which means our uncertainties are reduced, and therefore we can live with reduced partial factors. Or we know that confined concrete is both stronger and has greater deformation capacity than if it's not confined. So we've included within the second generation Eurocode some clauses that enable you to take advantage of that. You need to have them. You could argue no, many standards don't. Seismic standards will, but many other standards don't.
but it enables us to design structures more efficiently. So there's a strong argument to say, actually, it's the right thing to do. We've introduced coverage of some recycled materials in a limited way, greater coverage around durability. So a host of steps that we've taken that are around supporting that challenge of economic and carbon cost. And as I've already alluded to, assessment strengthening of existing structures, far greater coverage of that, which again is one of the critical things that we need to be able to do. So the flight from the UK to Australia and New Zealand is a long one. So I had plenty of time to count clauses. And these are the clauses in various specialist areas. You can kind of look at some of those and you could say, well, maybe do we need all of this? Let's go dig into one of them, okay? So that second order analysis one comes back to the point you made earlier. Go to another place in the Eurocode, yeah, where it's saying that when you're doing your analysis to calculate your action effects, that you can do a linear elastic analysis. You can use uncracked cross sections, massively simplifying and convenient to be able to use uncracked cross sections, because if you don't, then you need to know how much you've got. You don't know how much reinforcement you've got because you haven't designed it yet. Yeah. So being able to use uncracked sections is really, really helpful. So this is really, really convenient. But of course, that doesn't apply if we need to deal with second order analysis. And if we're doing second order analysis, then we have to take account of the effects of cracking and non-linear material properties and creep and all of those things, those 23 clauses of pain that you have to worry about in this case. And that's complexity that we bring in if we are doing a design where this becomes, and sometimes that's unavoidable. Standard piers, bridges, of course, this is going to be unavoidable. But you kind of get my point. But a lot of the complexity that comes in here is reinforcing that point around the choices that we make. So if I get back to that quote at the start, like life in general, our codes seem to get more and more complicated. I'm sure when I put that up and you looked at it, probably all do, we kind of look at it and we kind of think about complexity in a pejorative sense. Complexity is a bad thing. Is it? The kind of the point that I want to challenge people about is, don't we need those tools in the toolbox? As a profession, shouldn't we see our ability to deal with complex issues not as a point of shame, but as a badge of honor? It's a strength of us as a profession that we can deal with complexity. We shouldn't be looking at it really frustrates me if I'm in, say, a conference and an academic is presenting some theory and it's kind of beautiful work and they've got some really, some really elegant and mechanically sound theory they're presenting, and then at the end they go, but of course practitioners can't understand all of that, so here's a really simplified and crude approach which loses all of the clarity behind it. That really frustrates me. So we don't need to do that. We don't need to do that. So I think we have to challenge ourselves. I think we have to challenge ourselves and actually say, no, we shouldn't be afraid of complexity. We need it in our standards. We need those tools in the toolbox. Because when we're dealing with some of the complex things we deal with, we need to have these tools at our disposal. We shouldn't worry about it when we see standards getting longer. We shouldn't worry about it when we see standards giving us options to do things that are more complicated. We should see that positively. Although there's a but. There is a but, and it's an important but. Is that doesn't mean that we should accept standards that are unduly cumbersome and that don't provide us with relatively simple tools for doing relatively simple jobs. And those two things are not in conflict with one another, because I'll come and talk about in a minute. I think you can have both. So, the three looking forward ones, okay? First, about achieving ease of use. If you read this really quickly, you might have noticed that it starts off talking about simplification, and then it moves into talking about ease of use. One of the things that I did when I took over as chair of TC250 is I changed the conversation. And we stopped talking about simplification because simplification implies dumbing down. What we really focused on was thinking about ease of use. And when we embarked on this huge program, we set ourselves two overarching objectives. The first is that we should enhance ease of use. The second was to achieve exemplary levels of international consensus. Now, this exemplary levels of international consensus is a kind of talk in its own right. I can tell you, trying to work with, corral 34 countries to arrive at a consensus position is just it's a huge privilege to be able to do that, and it has its moments. But we're not going to focus on that now. Tonight, we're going to focus on the enhanced ease of use side of things. So one of the first things that I did when I took over as chair of TC250, so I established an international panel, 16 experts. We did a lot of wider consultation to understand what ease of use meant to us. And we developed a position paper. It set out a vision. Importantly, it set out 5 pillars that we were going to lead this through. And all 34 countries came behind support of this and this approach. A really key initial step was to agree who our primary audience was. It's kind of true, whenever you write any report, I'm sure you will do this, whenever you write any report, you do any kind of presentation, the first thing you have to ask yourself is, who's my audience? And that becomes even more important when you've got big teams of people, because they may have different ideas about who the target audience is. So really important to get a consistent position on who the target audience is. So we spent time, we arrived at this and said, this is our target audience. These are the people who are primarily writing. And it has really important implications, actually, because by defining it in the sense, competent civil, structural, and geotechnical engineers, typically qualified professionals, able to work independently in relevant fields, which you all know from working, typically when people have been working for 4 or 5 years or so, you just kind of reach that point, often around chartership in the systems that we operate in, that's the kind of point where you start feeling more confident to work independently. So that's the target audience. But it says something really important about how you draft clauses. You're not drafting clauses for anyone. You're drafting clauses assuming a level of competence. It's really, really important. It means that when you're interpreting a standard, this is true of all standards, but when you're interpreting a standard, because standards are written for competent engineers, you can't just arbitrarily take that sequence of words and just decide that you're going to interpret it in whichever way happens to be linguistically favorable to you. Because you're a competent engineer, you need to understand the underlying structural mechanics and interpret it properly. And part of being clear about this, clear about our primary audience, is kind of an expression of that point as well. The next step, and it was a really important next step, was to say, okay, but we've got lots of other users of the Eurocodes, and what we need to do is to be clear on what our intent is to support. So that they're not our primary audience, but we're still going to try and do something for them. So for our primary audience, the development Eurocodes, we said we will aim to produce standards that are suitable and clear for all common design cases without demanding disproportionate levels of effort to apply. Okay. That's our statement of intent for our primary audience. But expert specialists will aim not to restrict innovation by providing freedom to experts to apply their specialist knowledge and expertise. I'll come back to that one in a minute. For educators, we will aim to use consistent underlying technical principles. A piece of concrete really does not know whether it is a bridge or a building. Yet there are standards around the world that would imply that it behaves differently. Now that's tricky if you're teaching students about the behavior of concrete. So within the Eurocodes, we've said we want to be consistent so that we can educate our engineers in a consistent way. Regulators, really interesting, 34 countries, different regulations, getting that to fit together.
So I talked about expert specialists. When you're drafting standards, there are very specific things you can do to try and support this. This isn't like an aspiration. Specific things that you can do, and one of the key things you can do in this space is the way in which you express clauses. So in the Eurocodes, we use 3 different verb forms. Shall is a requirement, should a recommendation, may a permission. The shalls you have to do. The shoulds, well, you can do something alternative provided that it's technically justifiable to do so. So one of the things we've sought to do is to not have loads and loads and loads of shall clauses. And actually to migrate some of those into should clauses, some of those into may clauses, and then that gives experts greater freedom to be able to apply their expertise. And then talks about those other pillars. But you can see right at the top, in terms of the principles and priorities, clarity and understandability, ease of navigation, and a host of other innovations that we brought into this program, which have supported this. But the key point there is just, we talk about simplification. I think the conversation should be about ease of use. The next thing, again, looking forward, and this is not something which I invented. It's kind of common within standards that you have sort of simplified approaches and more sophisticated approaches. But what we find in some standards now in FIB model code, and this was formalized by a friend Aurelio Mattoni in Switzerland, the notion of levels of approximation. That within our standards, we can define different levels of approximation, methods with different levels of approximation. The concept being that as we use more complex methods, yes, they will take more time to do, but we will get greater accuracy of results. And again, if you're dealing with existing structures, the kind of point that Aurelio is making in this paper is that if all you do is use the simplified methods, you pay for it with much more extensive strengthening work. And then as you progress through the levels of approximation, then you increase your spend on the engineering design, but you reduce your spend on strengthening the structure. And what I really like about this is this way of thinking, is this idea that we should just be putting much more transparency into our standards in terms of these different levels of complexity, different levels of sophistication, different tools that are available to us. And I think as someone who spends time negotiating contracts with clients, that you want to, actually, if you've got this transparently set out in the standard, it's easier to define the scope of works. And also to have, in the ideal case, sort of mechanically consistent models with different levels of refinement so that you don't have the problem which we do have with the first generation in places and happens in many other standards around the world, where you have a simplified method and a more complex general method, and sometimes the simplified method gives you a better result. It should never really be like that. It's like if you're going to do the work, you should get a benefit from it. And so that's nice. If there is an interesting question, yeah, right, the boundary conditions and something else we'll dig into, but I know we're getting close to time, so I'm going to get close to wrap. But look, there's 2 things. The third one, and I think it's one of the most important ones, is that I love libraries and I love working in libraries. As John heard me say yesterday, and the reasons that I love working in libraries is if I look up, I see all of those books, and it reminds me that whatever issue I'm thinking about, someone far smarter than me has probably spent much longer thinking about it than I'll ever have the opportunity to. And with a bit of luck, they've shared some of that wisdom in a book. But that's not the future of standards. That's not how we work. That's what our offices look like these days. The WSP ones tend to have fewer plants, don't they? But other than that, that's kind of how it works these days. Earlier, I talked about page counts. I kind of lent into that space of thinking about things in a paper-based, okay, maybe it's a PDF, but I was thinking in those terms. As I was traveling
over, I did a little search on how many pages there are on the internet. There are billions and billions of pages on the internet. When was the last time you heard someone say, oh, I used to really like the internet, but boy, it's got so long. No, it's not the issue. The issue is how you find the stuff. It's how you navigate the information. And so the future of our standards, the future of the way in which you consume the standards, is it needs to be digital. And that's not a pipe dream. So I've talked about the Eurocodes work. One of the other major standardization programs I've been involved in was supporting national highways in the UK with the complete transformation of their design manual for roads and bridges. They had a real problem. 400 standards, 15,000 pages long, getting more and more out of date, struggling to update it. It's getting longer and longer. And I did a review for them. We made some recommendations. We worked with them in partnership to develop those. And I remember us writing, I remember sitting down with the National Highways, and we wrote down these 11 recommendations. And number 11 said that if this is going to get, basically, if this is going to get tackled as a program at pace, then it needs to be future-proofed for developments in digital technology. And it's a huge credit to the Highways board that they brought into that. And that what we did at the same time as updating all of those standards was that there was a complete digital transformation of the way in which it was done. And so we supported them in developing a platform for authoring, but all of their standards are not documented, they're a database. That database can link through APIs to publish the standards, but also to enable interfaces with analysis tools, whatever else. The departure system links across into this. It's a whole index manager, because normally when you sign a contract, you lock in the standards at that point in time. So now you can literally move a bar and it'll tell you what the suite of standards were that were applicable at that point in time. And the authoring platform, this is going to test the link, isn't it? That's working. The authoring platform includes automatic checking of compliance to the drafting rules as you go. And it also enables all of the commenting. So when you send the documents for review, all of the comments come into the system. When you're authoring, you have to provide background to every clause. That's within the system, because sometimes the background to the clauses is quite weak. It's kind of confession on standards writers. You know, sometimes we haven't a clue. And you're sort of sitting there and thinking, well, we've got to see something. So the best we can come up with is what 5 people in the room came up with at that point in time. You know, sometimes that's what happens. Sometimes what also happens is once you've done that, people like using the standard assume that you knew the answer. You know, but there were 10 PhDs that had come up with the fact it was 3. You know, sometimes it's just the best you could come up with at that point in time. It's really helpful to write that down. Not necessarily for public consumption, but it's really helpful if you're looking at a departure to know what the background was to these things. And doing this, you know, National Highways got some real benefits of this. Half the length of the standards, reduce the time to produce them by 80%. The best they'd done in any year previously was to update 30 standards. In 1 year, we did 272. And really substantial savings they generated for, really substantial savings. And it's hugely, and they're the heroes of this story, because they took a risk, they invested in this, and then they derived really, really significant benefit. So some brief conclusions, and hopefully I haven't too much over time. And these are really short. So my point I'm trying to make is that there's kind of an orthodoxy out there. I hear it said a lot. We want simple standards. Yeah, we have to recognize what the cost of that is. Yeah, simple standards inhibit us, and they have unaffordable sustainability impacts. You know, for design, they'll lead to inefficient use of materials. For assessment, they'll lead to situations where we have to strengthen structures that we might not need to. Okay.
Simple standards come with a price. But this is what I was saying earlier. It doesn't mean that our standards need to be unnecessarily complicated. It doesn't mean that we want cumbersome standards. So how do we achieve that? Firstly, that focus on ease of use, not simplification, not dumbing down, ease of use. The second, to think about how we achieve transparency between putting into the toolbox different levels of sophistication, and we provide transparency in that through maybe that levels of approximation type approach. Probably the most important one, to be honest, that kind of disappoints me, but the National Highways was able to make so much progress, but actually the standardization community around the world is not. I mean, people are working on it, ICE is working on it, CEN's working on it, but they're not making the progress that the National Highways make. Because the future development consumption standards will be digital. And that's where we need to get to. And it transforms their use. It means we can integrate them into workflows. We can use them as part of a knowledge ecosystem. So when you're reading that clause, you're thinking, I'm not quite sure what it means. Shouldn't we be able to just click on it, go through to that YouTube video that explains the background to that clause, or find that sample calculation? That's the future. That's the future. That's me. Thank you very much.
Thanks, Steve. I look forward to the future of YouTube videos that explain everything. Conscious of time, we're basically perfectly at 7. So there's a quick question or two, we'll take it. Otherwise, you can always approach Steve right afterwards. So if there's no questions online yet, does anyone have a quick question from the audience?
Okay, at the end there, you talked about ease of use, and with Eurocodes, you get quite easily lost within lots of documents because you got the main code, you got another code that you're referring to within that same part, then the national annex and the business document on top, and you get a designer's guide, you can quite easily get lost. So is there a plan for something similar to the DRMP?
The MOB stuff. So one of the really important differences between first generation and second generation is the first generation of Eurocodes was released essentially as PDFs to national standards bodies. The second generation of Eurocodes, they're being released both as PDF documents, but also in XML form. So there's lots of work to be able to have them in XML form. The fact they're in XML form opens up the possibility to do all sorts of interesting platform type things. So the way that will play out, I don't know exactly, but to me, it just seems that there should be a market for people to be able to, if you've got them in XML, you should be able to press a button and pull in national annex values. If you've got the main part and the bridge part, you should be able to integrate them, and this is not my job to do this. It's not really CEN's job to do it, but it's definitely our job to try and enable it, and that's what we're trying to do by having XML versions.
Great presentation. Standards often are interpreted with minimums.
Yeah.
And the shoulds often get into eliminate minimum. The mays eliminate it. And then it's very easy for people to think, well, okay, it's not just the minimum, it's actually good practice.
Yeah.
Good practice is the minimum. So how do you kind of encounter the educate? Because it's a challenge we have in all to be operating. Good practice is often above the minimum.
Well, and I think I could unpack this one in multiple different directions. I think, I suppose the place I want to start is that we call these things design standards, but they're not really. In fact, when they're translated in other languages, they don't use quite the same term. They're really verification standards. So I think that in terms of, my initial reaction to the question is good design is a much broader and holistic thing than compliance with a standard. Standards, for all the reasons I outlined, are really, really important, but satisfying a standard is a necessary but not sufficient condition for good design. It's really important. I think, one of the other areas I've been challenged on somewhat is that there's a guy, Chris Wise, a very eminent engineer in the UK, very, very brilliant engineer, and he challenged on saying, we put in these safety factors, but shouldn't we have an upper limit? Shouldn't we have something that says your partial factor shall be this, but no more than that? Because actually, when you go and there's been, I'm sure it's the same here, but there's considerable research done in the UK looking at actually the wastefulness of designs. An awful lot, particularly in the buildings side, an awful lot of wasteful designs. And so again, there's an interesting challenge there about, you're saying about minimums, but actually people can go too far, and that has consequences too. My response to Chris was I absolutely appreciate the sentiment. I don't think it's a place for standards. I think it's a place for regulation to drive that. But I think there is also, it's the standards have a function. I kind of talk about it because I want people to understand they have a function, but often they're kind of ascribe to them or expect them to have a different function. And it's really important that we understand what they're for, use them appropriately, and but also challenge ourselves. I mean, that's just the final thing I'll say on it is that who writes standards? We do. I got involved in the development of standards, and particularly at the European level. Not because at the time I had some kind of, bold aspiration to kind of, it wasn't some big personal mission or something. It was pragmatic. It's just a pragmatic view that says standards are important. And I want to be in a position to contribute in this space. And what we need is lots of people to contribute in this space, because if we all contribute in this space, we end up in a better place.
It's a perfect segue. We've heard the European model in national highways. In the New Zealand context, the concrete professors are looking at revising 3101. So if any of you are particularly passionate, you can get in touch with the lecturers at University of Canterbury or Auckland. Rick Henry was my supervisor, so I know that there's moves to start ramping up 3101, 304, 3404 are still codes going for revision now, I think, with HERA. Steve and I just came from a really interesting conversation with NZTA about how do we update the bridge manual. What is minimum? What is these standards are for us. So the calls out there, get in touch with your leading practitioners or academics or NZTA other clients. If we want to be efficient, let's get involved. So thank you. Yeah.
It's also a lot of fun, and it's really interesting, and it's really skilled. Actually, it's really, really skilled, and it's a great skill to have. But let me just say thank you so much for coming this evening. To the people online, I wandered around, I know, so I hope you could hear me okay. But thank you so much for attending. I hope that it was enjoyable, and to everyone in the room, it's been a real pleasure to be here this evening. Thank you ever so much.